Welcome. We are very pleased you have joined us for an overview of BTU Comfort Systems patent pending radiant heating and cooling system. I am Michael Sullivan, one of the inventors, and will be your host. Today you will be presented information, details, and videos that demonstrate how the system works and how it can be installed in existing and new construction homes. Radiant heating is a well-recognized choice as a standalone mechanical heating system. Radiant cooling is gaining notoriety and provides an alternative to forced air systems. Together, radiant heating and cooling can be your single-source mechanical system. Solar thermal hot water heating, typically known as domestic hot water heating, can easily integrate into BTU Comfort System panels, delivering heating and domestic hot water. BTU Comfort System panels can be used for radiant heating and cooling from the floors, walls, and ceilings. The panels can also be placed on the exterior of the structure to capture solar thermal heat. In some locations, the panels can provide supplemental cooling from deep space. Towards the end of this program, you will see an actual sample demonstration of panels, tubing, and stucco installed. Lighting is one of the major contributors to heat gain within a structure. Kitchen cooking appliances, people, laundry equipment, and refrigerators are additional factors that need to be taken into account when designing a system. Materials selected before a structure is built have lasting effects on the mechanical system requirements well into the future. Wall types, 2x4s, 2x6s, SIPs, ICFs, and a host of other choices can dramatically change the heating and cooling loads of a structure. Windows are a major source of heat transfer. The home's exterior can be utilized by BTU panels to capture solar thermal energy for hot water production. Solar thermal production is achieved by pumping a freeze-proof solution of fluid through the panels as the sun warms the structure's walls, roof, or decking. Captured heat can be used for interior radiant heating and domestic hot water or similar processes where a low supply water temperature is needed. In some areas of the country, night sky supplemental cooling may be achieved. Here, the cooling panels are best oriented perpendicular to the night sky. Here you see how the panels can be placed at the ceilings, floors, or walls to provide heating of the structure's internal rooms. Traditional modulating condensing boilers, air-to-water heat pumps, geothermal water-to-water heat pumps, reverse cycle chillers, and natural processes can be used to provide heated water. Same panels that were used for heating may also be used for cooling. You can split the panels, cooling from the ceiling and heating from the floor, or you can combine the panels, heating and cooling from the ceiling. And additionally, you can add walls if another surface is required or desired. Let's take a look at what happens in the cooling season with panels placed at the ceiling. Hot air rises and is absorbed by the cool panel surface. In turn, the embedded tubing with cooled fluid running through it absorbs this heat and transfers it out of the building. Cooled air begins to fall towards the floor. This cycle repeats over and over, silently providing cool comfort. Each zone can have its ideal temperature set for the comfort level desired. Because the panels are located at the ceiling, there is no limitation to the panel's surface temperature. Unlike a floor system that is limited to 62 degrees at the surface, which subsequently limits the total output conditioning available, BTU Comfort panels can achieve larger cooling loads by allowing a lower panel surface temperature. The dew point is monitored zone by zone, and the system has the ability to close the supply water circulation. Both heating and cooling can be achieved from a single source ceiling radiant system. In the heating season, there are a couple choices for heating. Use the floor or the ceiling. Let's take a look at the floor process. The heated fluid travels through the tubing embedded in concrete. This entire surface mass heats to an ideal temperature somewhere between 76 and 86 degrees at the surface to maintain a comfortable interior space. Heat radiates to cooler objects, heating them. Heat goes to cold, seeking an equilibrium of temperatures. Because of the large amount of mass, rapid changes to temperature settings are not feasible. Typically, it takes between 4 to 8 hours for a change in a thermostat setting to take effect. In this example, a rapid response BTU panel heating system achieves the same comfort from the ceiling. There is a balance of mass that responds to temperature changes with great speed, yet has retention flywheel properties as well. Tests reveal the mass has properties to continue to provide conditioning for a little less than an hour without input. This system can go from heating to cooling in a matter of minutes. The surface temperature of the panel is not limited to 86 degrees like a floor system. This allows for more flexibility in overall system design. Select any or multiple floor materials and BTU panels will operate at a single source supply water temperature. There is no need for multiple supply water temperatures to accommodate differing floor surface materials. Both cooling and heating can be done by a single system at the ceiling, saving installation labor and overall system costs. Let's change directions here for a second and take a look at solar thermal heating, where the BTU Comfort panels are placed on the walls or underneath the roofing or on the deck of a structure. Solar thermal production is achieved by pumping a freeze-proof solution of fluid through the panels as the sun warms the structure's walls, roofing, or deck. The captured heat can be used for the interior radiant heating or domestic hot water or similar processes where a low supply water temperature is needed. Depending on the building's orientation the number of panels, and your storage capacity. You can capture varying levels of thermal heat for use right then and there, or for use later on in the day. In a sister company, Radiant Design, I've done some solar systems where we've captured the heat during the day, stored it, and then utilized it at night to shut the boiler down. Doing so saves about 40 to 50% on the fossil fuel use. A single-source radiant system can provide both your heating and cooling. To keep the air fresh and filtered, air movement must be achieved. In this example, an ERV is used. They are simple devices requiring minimal ducting. You may elect to provide a substantially downsized conventional air system for filtration, and the radiant heating and cooling is the primary conditioning source. Say, for example, a 5-ton unit, you might put 2 tons of air and 3 tons of radiant heating and cooling. Stage these mechanical systems, and you get the best of both worlds.